What's up, everybody? Welcome back. And today we're doing some more deep ML questions. Today we're going to focus on problem number 2, transpose a matrix, which is an easy problem. And if you're new here, DeepML is a great website to practice machine learning coding interview questions. And for me, as someone who has several years of experience in machine learning, this is my bread and butter. So it's very fun for me to do these. So let's dive right in. So in transpose a matrix, what we want to do is write a Python function that computes the transpose of a given matrix. So if we have a matrix of size 2 by 3, like this matrix A, we transpose it and we get a matrix of size 3 by 2. So what we're doing here actually is, if you can imagine a diagonal across this rectangular matrix, transposing a matrix is flipping this across the diagonal. You can also learn a little bit more about this topic over here, which is very nice. So let's focus on the code and we'll see how we do it. So we're going to solve this in two ways. First is going to be with explicit Python, which we're going to learn from, and then we're going to see what's going to be very slow. And then afterwards, we're going to solve it with Python, with NumPy, which is going to be way faster, and that's actually what you're going to do in real life. But it's not very explicit, and it's hard to understand what's happening. So without further ado, let's dive into the code. So we're given a matrix A as a list of lists. So here, it's going to have m rows and n columns. M rows and n columns. And this we're going to get by checking how many lists are in A. This is going to be how many rows we have. And each list over here has n columns. So this means that it is of length n. So to get this number, I just need to see how long the first element is, with the assumption that all the lists inside A are of the same length. Now for the transposed matrix, we're going to actually do the opposite. So instead of having m rows and n columns, it's going to have n rows and m columns. So let's initialize this matrix. So what we're going to do is we're going to initialize it with zeros. So we'll have each row in this matrix now is going to be of length m, and we're going to have n of these rows. So this means that this matrix is going to be of size m n by m, and our original matrix A is of size m by n. So now let's start filling it up. So let's start iterating over the rows and columns of the new matrix. So the new matrix transposed A, it's going to have n rows. Very confusing. And each row is going to be of length m. And the transposed matrix at index I, j, by definition, is going to be the original matrix at index ji. And that's it. That's the definition of a transposed matrix. We just need to return it. And let's see if this runs. We'll run our different test cases. We'll see if this works. And it does. It passed all the test cases. That's great. Now let's try to solve it one more time, but this time using NumPy. So NumPy is going to be way faster, like significantly faster, because it's going to run with vectorized operations in C compared to our very slow double for loop in Python. And what we just need to do to transpose a matrix, so first we'll convert it into a NumPy array. And now we just need to transpose it. So if we do dot big T, that transposes a matrix, and we need to return it as a list of lists, same as the original format. So we just call this toList function, and that should do the trick. Let's see if I'm correct. Running the test results. And yep, yes it did. So as you can see, it's way more compact and much faster. However, it's very hard to understand what's happening here. And in interview, interviews, they're probably going to ask you to write the native Python. So I hope you learned something over here, and I'll see you again next time.